Logic has been around in some form for over 50 years, and it looks like it will be around for that long again. But does that mean that new logic development is over? Are there no new tricks left for logic? In this episode, we're going to look at two of the newest types of logic, configurable and combination logic, just to show you how logic keeps adapting to fit the times. The most common types of logic device used today are the small, single, and dual gate devices. These are very small, convenient devices which allow a designer to put down just one or two gates onto their design to solve some small signal issue. Maybe a bit more drive current, a level shift, maybe an external correction to a signal on an ASIC. But it can be a bother if you have to use a lot of these small packages, which is exactly why configurable and combination logic were invented. Suppose that you have a variety of different single gate devices in your design. You got a couple of AND gates, a couple of OR gates, some inverters, and XOR too. While this solves your design issue, it sort of makes a mess out of your bill of materials. You have to order a bunch of different part numbers and keep track of all of them. Now, wouldn't it be great if you could just buy one device, then configure it to be the AND gate here, and the XOR here, and the inverter there? Whatever you needed, that part could do it. Then you would only have to order one part number, and you could buy a lot more of that one device, so you might even get a quantity discount. Configurable logic gives you just that. It's a single device that can be configured to be different functions. Now, don't confuse this with programmable devices like PALs or ASICs or EPLDs. Configurable logic devices do not have to be programmed before you use them. They are simply configured to take on different functions by applying different voltage to some of the pins. So all configurable logic devices start out the same way. It is simply the way that they are wired onto your circuit board that gives them their personality. Let's look at one of the common configurable logic examples, which is the 74AUP 1G58. There are 6 pins on this device. 3 of them are fixed: power, ground, and the output signal. Now think about those other 3 pins. Depending on the function, you only need 1 or 2 of those pins for the logic input. By moving the input pins around or fixing some of those pins to VCC or ground, you can then wire or configure that device to have different functions. Here are the 6 different functions that this particular device supports. One part number can be an inverter, a NAND, an OR, or several other different functions. Is it magic that does this? Hardly. Here's the diagram of the internal circuit of this device. As you can see, it's simply a series of gates with a NOR gate as the final gate and some additional logic built in for a particular function. Now that you know how it's made inside, you could actually make your own configurable logic circuit, but it would take you 4 more packages to do it, and that's what you're trying to avoid in the first place, right? As a bonus, keeping all of these connections inside a single package means that several layers of input and output buffers can be removed. So this single configurable logic package will actually have higher performance than if you built this same circuit using discrete individual packages. It's a performance gain. Configurable logic is available in 3 different logic families. So there are solutions for designs operating from 0.8 volts up to 5.5 volt supplies. And of course, a variety of package solutions to fit pretty much any size design. So are you ready to reduce your bill of materials and try some configurable logic? Look at your schematic and create a list of the variety of single gates that you use. Then take a look at this chart and see which function family, the 57, 58, 97, 98, or 99, can cover all of your list of particular functions. Pick your process, AUP, LVC, or AXP, depending on your operating voltage. Pick your package, and you are on the way to simplifying your design and your bill of materials. The only trouble with configurable logic gates is that you still only get 1 gate per package. Suppose your design is really tight on space. Now, wouldn't it be nice to combine some of these single gates into a fewer number of packages? Now, if all the gates are exactly the same type, like they're all inverters and they're all OR gates, that's pretty easy to do. You just buy the 2-gate version or the 3-gate version, like the 74AUP 2G08, which has 2 AND gates in it, or the 74AUP 3G04, which has 3 inverters inside of it. But suppose you have one OR gate and one AND gate. Can you find a single device that has this combination of these 2 different functions inside a single package? With combination logic, you can. There are 3 types of combination logic. The first is called single gate. It has a combination of 2 different types of gates included, but the gates are connected in series, one into the next. So from the outside, it looks like a complex, but a single gate. For example, the 74AUP 1G3208 is an example of this. It has an OR gate feeding into an AND gate, both of them inside a single package. The next type is called the dual gate combination logic. In this device, there are 2 different unconnected gates in a single package. The 74LVC 2G0200 has one NAND gate and one NOR gate inside a single package. 2 different types of gates, one physical package. And then finally, there is a triple gate combination logic. In this device, there are 3 different unconnected gates in a single package. The 74AUP 3G070417 contains one each of a buffer, an inverter, and a Schmidt trigger buffer. It is the triple play of logic gates. Now think about it. If you do the math and you count up all the possible combination of gates in combinations of single, dual, and triple, you get something like 40 different single gate combinations, 255 double gate combinations, and a huge 355 triple gate combinations. Of course, all of these haven't been made yet, but if there's a good enough business reason, it wouldn't take long to create one of these just for you. So there you have it. Single logic gates are only the beginning of the options awaiting you. Take a look at the variety of single gates used on your design, and you may find that configurable logic or combination logic might just be the solution that you need to get your project on size and on budget. Looks like that old dog logic can still learn a new trick once in a while.